All right, welcome to this last video where we're going to talk about metallic bonds. And so let's talk about what we talked about so far. We talked about ionic bonds, which is between metals and nonmetals. And then we talked about covalent bonds, which are between two nonmetals. So what do you think metallic bonds are between? Well, metallic bonds are between two metals. And so we have not actually talked about metallic bonds too much this year, so this is going to be a little bit of new information. So the chemical bonding that results from the attraction between metal atoms and the surrounding sea of electrons is called metallic bonding. And so ionic bonds transfer electrons, covalent bonds share electrons. And the way that we describe electrons for metallic bonding is we say it's a sea of electrons. We're going to talk about that as we go here. So, but if you think about a metallic structure, I mean, it does kind of look like ionic structure, but it's actually different. And so we'll talk about how it's different here. And really what's different is the electrons are free to move around. And so if you take a look at this picture, look at the electrons, the little blue dots. Those electrons are not stationary. They're not stuck to one atom. They're able to freely move from one atom to another. And that makes a lot of sense because metals tend to lose their electrons. So if you have a bunch of metals all together, metal atoms all together, they're all sort of freely losing their electrons. And so those electrons are able to jump from one atom to another. Now, as it turns out, electricity is the flow of electrons, and so that kind of makes sense why metals are able to conduct electricity, because those electrons are able to freely move around. And so let's talk about how that affects the properties of metals. So metals do have a low effective nuclear charge. That means that their attraction to their valence electron is low as well, and so because they have a low attraction to those electrons are able to freely move around. So again, those electrons have very low attraction, so they can jump from one atom to another. All right, so most metals have empty orbitals. All right, so they have empty valence levels. And so when you think about like a metal, like the metal on here, really what's happening is the atoms themselves, the electrons, are freely moving around, which means that those metal atoms, the valence electrons, are not really there. They're kind of gone because those valence electrons are freely moving around. And so what happens is these orbitals overlap between the metal atoms, and that's what allows the electron to roam freely. All right. So the electrons are also said to be delocalized. All right, so think about what the word localized means. So it's like localized in a certain location. Well, if they're delocalized, that means they're not in a very specific location, and that is because they're able to freely move around. They're not in one location, they're freely move around. And so again, they're delocalized, not in one location. The freedom of electrons to move between metal atoms accounts for the high electrical and thermal conductivity. So metals are able to conduct electricity because, again, electricity is the flow of electrons, and so electrons are able to flow in metals because metals don't hold on to those electrons. Now, metals are also able to absorb a wide range of light, and what I want you to do is think about, Unit 3 when we talked about how light would come in and the electron would absorb that light and it would jump to a higher energy level. Well, because metals don't hold on to their electrons very well, those electrons are actually able to get so excited that they fly off. And what ends up happening is that when light comes in, those electrons absorb that and it flies off. And when they fall back down, they do emit the energy back in the form of light. And this accounts for the shininess that you see in certain metals. And so some metals are shiny because of this fact here. So there we go, shiny. Now, most metals are also they're also easy to form into different shapes. And this is because the metallic bonds, again, kind of like ionic bonds, the metal atoms aren't really bonded to one specific atom, but rather they're sort of they're just next to each other, and what they're really attracted to is they're really attracted to the sea of electrons. And so because the atoms are not really bonded to one another, they're able to freely move past each other, which is why you're able to take a piece of metal and like hammer it into a flat piece of metal. So you're able to take the metal and hammer it flat, and you're also able to bend it and form it into different shapes. Now, what this is called malleability, and so malleability is the ability of a substance to be hammered or beaten into thin sheets. And so again, if you think about the structure here, the positive ions, those positive metal ions, they're not really bonded to any of the atoms next to each other. In fact, do you see how, because they're positive, that they don't really want to stick together, that they're okay sliding past each other? And I know that's going to bring up the question, well, why don't they just repel each other? Well, what's holding them together is that sea of electrons. It's the fact that there's electrons there that they are attracted to. Now, so here's a picture of a flat sheet of metal into a little tin guy. All right, so ductility is the ability of a substance to be drawn or pulled into wire. So it's the ability of a substance to be stretched into a wire. And so the reason why they're able to do that is, again, because the atoms are able to freely go past each other because they're not really bonded to each other. They're really just within that sea of electrons there. All right, so that's pretty much the gist of all the bondings. So we talked about ionic bonds, covalent bonds, and now metallic bonds. Ionic bonds, electrons are transferred. Covalent bonds, electrons are shared. In metallic bonds, the electrons are said to be a sea of electrons, and those electrons are free to move around. And so because of what the electrons are doing, that affects the properties that those different bonds have. And so really it comes down to what are the electrons doing. So if you remember what the electrons are doing, that'll really help you understand the different types of bonding. All right, so go ahead and watch that guided practice problem video, and I will see you in class. Come with questions.